For worksheet 14, question number 3, this question is asking us to find the excited state that a hydrogen atom transitions to if it starts off at the ground state. And one of the key pieces of information they give us is that this process has a wavelength of 95 nanometers. So again, if you're talking about a hydrogen atom and you're talking about transitions, one of the first things that should come to mind of what equations you can use is the Bohr equation. So here's the Bohr equation. And we can get from our problem, we can figure out what n initial is. It is the ground state, and for all ground states, n equals to 1. So this variable right here equals to 1. We are trying to find what nf is. And in order to do that, we also need a change in energy. Because we don't have this number right here, we need to think of some other equations we can use in order to get there, in order to get energy. So some other ones we can think of are energy equals to h nu. And however, because energy equals to h nu, we don't have anywhere to plug in lambda, which is wavelength. We have to think of another equation, which is c equals to h nu, and if you rearrange it, you get nu equals to c over lambda. So if we are able to combine this equation, these two equations, we can get E equals to hc over lambda. So we can, h is Planck's constant, c is the speed of light, and lambda here is what we're given, 95.0 nanometers. So using this equation, we can figure out what E is, and if we figure out what E is, we can plug it into the Bohr equation and solve for NF. So continuing that thought process, let's plug in some numbers. So if I plug in Planck's constant right here, and I plug in the speed of light right here, and I convert 95 nanometers into meters here in order for the meter units to cancel, in order to just end up with joules at the end, I can solve for my energy, which I get to be 2.091 times 10 to the negative 18 joules. So now that I have that number and I have that value, I can plug it back into delta E right here, which is the energy of the transition. And if I plug this in and set everything equal to each other, you notice I only have one variable to solve for, which is n final, or the excited state to which the hydrogen atom transitions to from the ground state. And if I solve for that, I just rearrange my equation to solve for NF. I get my final excited state transition to be equal to 5.